Okay, continuing with lesson 10.2, let's look at example 4. Find the equation of a parabola with a vertex at 0, 0. If its axis of symmetry is the x-axis, which by the way, of course, is a horizontal line, and it also contains the point -1/2, comma 2. So really what we see here is a parabola that has a vertex over here. -1/2, comma 2, of course, is going to be a point roughly up here somewhere. Right now you might think, well, this either means my parabola opens upwards or perhaps to the left, but the fact is we have an axis of symmetry. That's the x-axis. The axis of symmetry is a line that is going to be symmetrical about the vertex. It's going to go right through the vertex. It's going to allow us to reflect our parabola over itself. And if that's the case, we should know that our parabola should be opening up towards the left. It should be working this way. Otherwise, if it was opening upwards, if it was looking something like this, our axis of symmetry would be a vertical line. It would be, in that other instance, the y-axis. But what does it mean to have a parabola that opens up towards the left? We need y squared equals -4ax. Right now I'm just going to plug in my y value of 2. I'm going to substitute in an x value of -1/2. And of course 2 squared is 4. Here a negative and a negative make a plus. 2 goes into 4 twice. We have 2a is equal to 4, meaning a is equal to 2. Once I substitute a is equal to 2 back in, we will have y squared equals -8x. Okay, this next table here that I have highlighted is incredibly close to the table that we had from the last video. The big difference you can see on the far left is that our vertex is no longer at the origin. It's no longer at 0, 0. Instead, our vertex is some other point, h, comma, k. Notice as you go to the far right, this fourth column right here, where we have our equation. Notice that we'll always have an x minus h and a y minus k. X minus h is going to be in every one of these four equations, so will y minus k. We have to change the signs for both the x and the y coordinates of the vertex. But once again, we have some very similar behavior from what we saw on the front page. If we have something with y squared, and on the right side we have something positive, you'll open to the right. If you have a y squared equal to something negative, it opens left, and so forth. You're going to have similar behavior with your x's, opening up and down, of course, depending on whether you are positive or negative. Your a value is always the distance from the vertex to a focus. It is also the distance from your vertex to a directrix. Rather than memorize this whole table here, I think you can just use common sense, using your a value and then finding your focus and your directrix. Let's see if we could do such a problem right now for number 5. Find an equation of the parabola with a vertex at -2, 3. It is certainly a good thing to graph. Look, 2 to the left, 3 up. Here is our vertex. And we can see quickly that our focus will be at 0, 3. That's right over here. So with a vertex of -2, 3, our focus is over here at 0, 3. We can really quickly count how far our vertex is from the focus. You can see that we'd move 2 steps to the right from the vertex to the focus, meaning that our a would equal 2. Furthermore, what you need to realize is that when you have a vertex and a focus to the right of it, that means that the parabola opens towards the right. Now, if your parabola is opening up towards the right, it's this very top entry that we see. We will have y minus k, quantity squared, would equal 4a times x minus h. Very quickly, we know that our h is -2, our k is a 3. we would have y minus 3, quantity squared, equals, we'll deal with this a in just a minute, we have 4a, this would become x minus negative 2. Of course, we already talked about our a. Our a is 2. We found that distance from the vertex to the focus. We'll have 4 times 2 here. This becomes x plus 2. 4 times 2 is 8. The right side becomes 8 times x plus 2. Left side we have y minus 3 quantity squared. And of course, sometimes you'll be given information about a directrix instead. You very likely will have to use some different thinking to find some of these values. Let's take a look at number 6. Analyze and graph. I think what I really want to point out to you is that very often you will be given the equation of a parabola that is not in factored form. And we'd like to be able to factor this. And what we're going to do is something called completing the square. We'll have x squared plus 4x. Get your squared term on one side. Add 4y to the other side. And completing the square always involves first looking at your linear term, the number that is in front of the x, that is multiplied to x. And that you could even call your b term in terms of quadratics. You could say b is equal to 4. What you'd like to do is take half of that term. 1/2 of 4 is 2. I'm going to put a big star over here because we're not done seeing that. But after we take half of that number, half of 4, and we get our 2, and we make a little note that we're not done seeing it, now take that number that you've just taken half of, take the 2, and square it. 2 squared is 4. This is what you're going to add to the left side and simultaneously add to the right side. Now, when you complete the square, you have designed this problem to factor. And in fact, what you're going to see is, there's a reason why I put that star over there. This term that I put a star by could be positive and it could be negative, but it's what you will see as you do perfect square factoring. This is a plus 2, so I will write x plus 2 here. Sure enough, x squared plus 4x plus 4 would factor into x plus 2 times itself. On the right-hand side, I suggest factoring out of 4 as well. Why? Well, if you were to quickly look back on our table here, you're always going to have a 4a out in front of some parentheses. And hopefully you can see right now this looks very much like x minus h quantity squared equals 4a times y minus k. I hope we can quickly look at this problem and notice we have to change the signs inside these parentheses to find our vertex. Our vertex won't be a positive 2 for our x, but a negative 2. It won't be a positive 1 for our y, but a negative 1. So we have negative 2 comma negative 1. Take a look at this. We have 4a out in front of these parentheses. 4a would equal 4. That means a equals 1. Now if a is equal to 1, this is your distance from your vertex to your focus, also your distance from your vertex to your directrix. So quickly, let's take a look at negative 2, negative 1, 2 to the left, down 1 would be over here. Now our focus with a equal to 1, this is a parabola that opens upwards. I hope everyone would agree. If we were to go one step up, we would find our focus. This would be at negative 2 comma 0. If we were to move our vertex and move one step down, we would find our directrix. And our directrix, of course, then would be a horizontal line, y equals negative 2. Finishing this problem up, let's realize that the lattice rectum is going to be 4 units long. If I were to take half of 4, I would get 2. Remember that the lattice rectum is a segment that goes through your focus. So go to your focus, move 2 steps to the right, move 2 steps to the left, and sure enough, that would be a nice fast way to write or to graph the equation of this parabola. If you're ever in doubt if you've done this correctly, check these points. You'd see it should be 0, 0 is on this curve. If I plug 0, 0 into the equation, it should work. Similarly, negative 4, 0 appears to be a point on this parabola. If you were to plug in negative 4 for x, 0 for y, it should make that equation, the original equation, true. By the way, it does. For example 7, a satellite dish is shaped like a paraboloid of revolution, a three-dimensional parabola. The signals that emanate from a satellite strike the surface of the dish. They're reflected to a single point. By the way, that single point will be the focus. And the focus then is where the receiver is located. If the dish is 8 feet across at its opening and 3 feet deep at its center, at what position should the receiver be placed? Well, let's quickly make ourselves a picture and conveniently orient this parabola so that its vertex is at the origin. Make life easy on yourself. We know that the dish is 8 feet across. So I know that as I go to the very top of the dish, right down the middle here, I'd move 4 to the right, 4 to the left. You'd have a total distance of 8. This in no way means that we found our focus. Our focus would, of course, be the latus rectum, and we have no information to say that this distance, 8 feet across, would be going through where the focus should be located. It's 3 feet deep in the center. In other words, we have these 2 points. I can go 4 to the right and up 3. Similarly, I could go 4 to the left and up 3. If you look real quickly, you can see this is a parabola that opens upwards. From the very front page, we have x squared equals 4ay. I'm going to let x equal 4, and I'm going to let y equal 3, so I can find find a. 4 squared is 16. 4 times 3 is 12. When I divide by 12 and simplify, dividing by 4, I will get 4/3. A is your distance from the vertex to the focus. Your focus then should be 4/3 feet above the vertex. So we should place the receiver 4/3 of a foot above the vertex. So that would be an application problem. We're going to spend 2 days on this assignment, and the homework is right here, page 643, 644, 11 through 43 the odds, 47 through 66 all. Good luck to you.